Hey everyone, and welcome to this course where I'm going to show you how to use the CopyCat node in Nuke to perform some beauty work. In the shot I'll be working with today, there's an actor with a bruise on his face that needs to be removed. And I'm going to use CopyCat to train a neural network to remove this bruise so that I don't need to go through and remove it manually. After that, I'll show you how the effect can then be applied to multiple shots. So a quick introduction to CopyCat. It is a machine learning tool available in Nuke 13. If you would like to find out more on this node and machine learning in Nuke in general, then take a look at the machine learning section at learn.foundry.com/Nuke, where you'll find some introductory learning content which may help before you continue with this course. CopyCat has many uses, and beauty work is just one of them. But cleanup is a great way to utilize machine learning capabilities, as it's usually composed of a combination of tasks which can be time-consuming, especially if working with multiple shots. So in this example, I'm going to start with this shot of 340 frames. This is a .mov file, but you can also use an image sequence. Ordinarily, to clean up the bruise from the actor's face, a compositor would need to track the area that they want to clean up, mask whatever they don't want to edit, create one or more clean frames, move the patch to the original plate, and then match any defocus or lighting changes that the plate may have. So there are quite a few different tasks and separate steps that CopyCat will save you from doing. So the first thing that you'll need to do is really examine your sequence to understand what's changing throughout the shot, and then pick a few frames to clean up manually and use as a dataset so that we can then start the training process. A dataset is a number of image pairs used to train a network to perform a specific task. Image pairs consist of one input image and one ground truth image, where the input is the before and the ground truth is after the effect is applied. In this example, the before would be a single frame from the sequence, and the after is a manually created clean plate of that frame, where the bruise has been removed. A bit of information about making a dataset. You want to make sure that you have a really diverse selection of images, as this tends to produce the best results. So in this example, I want to choose frames where the bruise is being covered by a shadow, or where it has a specular highlight going over it. And I want to look for things like if there's an occlusion, if the camera is changing angle, or if there is a very strong change in focus. And choosing diverse frames for the dataset gives CopyCat more information to use during the training and can help to improve your results. Remember that this is the same no matter what effect you're using CopyCat for. The dataset should always be as varied as possible. I'm going to start by using these two frames for the dataset. You can't really use too many images, but be aware that the more frames you use, the longer the training is likely to take. Using too few frames, however, will produce an incomplete result, so it will take a bit of trial and error to find a good amount, and this will vary from task to task. You may want to start with fewer frames to avoid using too many unnecessarily, and then you can always add more later. So now that I've chosen the frames to use, I'm going to create frame hold nodes to represent each frame. Then I'm going to add a frame range node after the read node to set the frame range to 1 to 1. So they have a range of one frame and follow each other in sequence. If you prefer, you can also write out the chosen frames separately and then bring them back in as individual read nodes. So now you can highlight the frame hold nodes and add an append clip node. And now we've got our before images, I'm going to create a clean plate for our after images by removing the bruise from each of my chosen frames. But first, I'm going to duplicate the frame hold nodes so that I can work on just the two chosen frames. And then I'll start the cleanup, and I'll resume the video once that's done. So now I've created a clean plate for each frame by making a patch for the actor's face. There's a few ways this could have been done. I've used a combination of InPaint and RotoPaint nodes to get the exact result that I wanted. I've also written out the result for both frames and read them back in separately. You don't have to do this, it's up to you, whichever workflow you prefer, but it may be useful to write them out separately if you're using nodes that use GPU memory, such as InPaint, because CopyCat also uses GPU to train, And if you run the training without writing the images out first, it may interfere with your batch size and efficiency of the training process. I've also used a remove node at the beginning to remove the alpha channel and make sure the image we're working with is just RGB. We don't need the alpha channel for this task, and by removing it, we'll speed up the training as we only need to process 3 channels rather than 4. And then I'm going to add a separate append clip node for the clean plate data. Not all tasks require separate nodes. If you watch my Creating Maps using CopyCat course, then you can see that I used just one set of frame hold and append clip nodes. And this was because I was using separate channels for the before and after. However, for this task, we altered the RGB channel, so separate nodes are required. At this point, it's a good time to check that the append clip inputs are in the same order for both append clip nodes. If they're not, then you will have problems with your dataset and the training. So as I said earlier, the ground truth is the result that we're aiming for, which in this case is a face cleanup. However, as you can see, the effect that we're trying to achieve doesn't change a huge part of the image. So if we leave this image as it is, the training would take longer than necessary, as it would need to process parts of the image that doesn't change. So something that we can do to speed up the training process is to crop the image around the affected area, in this case the actor's eye, and then I'll just need to animate the crop as the bruise changes position when the actor's face moves between the 2 frames. Careful not to crop it too much, as you still want the network to be able to take a variety of different crops from the image. I'll go into a little bit more detail later about how the network takes crops from the image during the training process. Keep in mind that it's really important that the size that you crop your image is bigger than the crop size you select for training. This is an option in the CopyCat properties, which we will come to later on. So after creating the crop node, I'm going to create a new append clip node and connect the first pipe to the first append clip, which is the original chosen frames, and the second pipe to the crop node. And the reason that I'm using a second append clip node and not just applying the crop to the original frames is because it's important to not only feed the crop to the CopyCat, but also keep some full frames in the dataset as well. Otherwise, the training will start producing random results in the rest of the image. This is fine if you don't mind masking out the effect later, but for the purpose of this video and being efficient, I want CopyCat to learn where it should do the effect and where it shouldn't do anything. But do bear in mind, you don't need to have a full frame per cropped frame. So now the dataset is including both the original frames and the cropped version of the frames, making the dataset 4 in total. So finally, I'm just going to copy the crop and the append clip nodes and paste it after the clean plate versions, and I'll double check that the append clip inputs are in the same order for both. A good tip to remember is if the append clip node is connected to a dot node like this, you can copy that too, and it just saves a bit of time when pasting somewhere else in the network. So now we have a very clear data set consisting of a before and after that we can use to train the network. So I'm going to add a CopyCat node and connect the ground truth to the second append clip node and the input to the first. And now we have our dataset all ready to go. In the next video, I'll talk you through the CopyCat node and show you how to train the network and monitor the progress.